All right, let's take a look at our last example. Example 4. The base of a solid S is a circle of radius 1. For this solid, the cross-section slices perpendicular to the x-axis are equilateral triangles. Find the volume of this solid. Let's start with an image. So we've got this base that's -1 to 1. We have these equilateral triangles popping up out of that base. And we have all of these triangles filling up the space from -1 to 1. In two-dimensional space, it looks like this. And our sample cross-section looks like this. And it's equilateral, so we know all of the angles are 60 degrees. And we know that every single side, similar to the previous problem, the base is 2y's. And using what we learned in geometry, we know that if a triangle has a 60 and a 90, this other missing angle is 30, we know that the relationship between the sides in a 30, 60, 90 triangle is y, in this case 2y, and root 3y. So the long leg is root 3 times the short leg, if you remember from geometry class. So we would like to find the area of the cross-section. We know the area of a triangle is 1/2 base times height. We know that the base of this triangle, right here, is just 2y. And we know the height of this triangle is root 3y. Now, we would like these formulas to both be in terms of x. So skipping some of the math that was done on the previous problems, we know that y, using that sample triangle here, is just the square root of 1 minus x squared. So the base is just 2 times the square root of 1 minus x squared, and the height is just root 3 times the square root of 1 minus x squared. Now, piecing this information together, we can rewrite the area of a triangle as 1/2 times 2 square root of 1 minus x squared and root 3 times square root of 1 minus x squared. Now, simplifying this, we notice 1/2 times 2 is 1, and then 1 times root 3 is root 3, and then root 1 minus x squared times root 1 minus x squared is just 1 minus x squared. So this just becomes root 3, 1 minus x squared. Now, continuing on the next slide, we have our area, but to get the volume, we're going to integrate those equilateral triangles from -1 to 1. So we have the integral of root 3, 1 minus x squared with respect to x from -1 to 1. Let's pull the constant to make for easier integration. And then we'll find our antiderivative. Antiderivative of 1 is x. Antiderivative for x squared is 1/3 x cubed. So we have root 3 times x minus 1/3 x cubed. Then evaluating this at our upper and lower bounds, we get root 3 times 1 minus 1/3 times 1 cubed minus root 3 times -1 minus 1/3 times -1 cubed. Now 1 cubed is 1 times 1/3 is 1/3, and the -1 cubed is -1 times -1/3 is plus 1/3. So we get root 3, 1 minus 1/3 minus root 3, -1 plus 1/3. 1 minus 1/3 is 2/3, and -1 plus 1/3 is -2/3. So we get root 3 times 2/3 minus root 3 times -2/3, or 2 root 3 over 3 plus 2 root 3 over 3, or simply 4 root 3 over 3. And that's it.